Boyle's Law. The law was first published in 1662 by the Irish chemist and physicist Robert Boyle. It was independently discovered in 1676 by the French physicist Edmé Mariotte, which is why it is sometimes called the Boyle-Mariotte law in some regions. Boyle's law is a fundamental gas law stating that the pressure of a fixed amount of gas is inversely proportional to its volume, provided its temperature remains constant. This means that as volume decreases, pressure increases, and vice versa. Microscopic explanation. As volume decreases, the same number of gas particles occupy a smaller space. This leads to more frequent collisions with the container walls, which is measured as increased pressure. Mathematical formula. For a gas under two sets of conditions at a constant temperature, the relationship is expressed as P1V1 equals P2V2, where P1 and V1 are the initial pressure and volume, P2 and V2 are the final pressure and volume. Graph. A plot of pressure, P, against volume, V, produces a rectangular hyperbola. Conversely, a plot of pressure against the inverse of volume, 1 divided by V, results in a straight line. Real-world applications. Boyle's law is widely used across various fields. Scuba diving. As a diver descends, water pressure increases, compressing the air in their lungs and equipment. Human breathing. Inhaling increases lung volume, which lowers internal pressure and draws air in. Exhaling decreases volume, raising pressure and forcing air out. Syringes. Pulling the plunger increases volume and decreases pressure, drawing liquid into the barrel. Aerosol cans. Highly pressurized gas expands rapidly when the nozzle is pressed, pushing the product out as volume increases. Weather balloons. As a balloon rises, atmospheric pressure drops, causing the balloon to expand significantly until it eventually bursts. Opening carbonated beverages. Soda is bottled under high pressure to keep carbon dioxide, 2,2, dissolved. When you open the cap, you suddenly increase the available volume for the gas. According to Boyle's law, this increase in volume causes a rapid drop in pressure, allowing the CO2 to expand and form the characteristic bubbles and fizz. Whipped cream and aerosol dispensers. Canned whipped cream uses a pressurized gas, usually nitrous oxide. Press the nozzle. When you press the nozzle, the gas is released from the high-pressure can into the lower-pressure atmosphere. This sudden expansion, increasing in volume as pressure decreases, whips the cream into a light, airy foam. Vacuum sealing and packaging. Food manufacturers use Boyle's law to manage air inside packaging, such as bags of potato chips. If a sealed bag is transported to a higher altitude where atmospheric pressure is lower, the gas inside the bag will expand in volume to balance the lower external pressure, which is why snack bags often appear puffed up during flights or in mountain regions.